Hello everyone and welcome back to the AI channel. I'm excited to introduce you to the all new Chia 2.0 interface, and trust me, it's looking sleek. If you're a Chia lover like me or simply curious about the world of Chia farming, you are in for a treat. Today we'll be reviewing the latest update that just hit the scene, the Chia 2.0 version, but here's the kicker, it's a hard fork and a soft fork, so there are several implications here. In this video we'll explore all the updates brought by this latest version. First thing you'll notice is the revamped graphical user interface. It's not only visually impressive but also packed with functional improvements. Now, if you are a pro farmer or even if you are getting up to embark on your Chia farming journey, this update holds immense significance for you. Secondly, we'll be running the latest Bladebit 3.0 plotter integrated seamlessly into the GUI. We'll compare plotting on disk, on RAM, and with a GPU. Let's see what works best for you. We also need to start answering some of the harder questions, right? Is compressing new plots a smart move? How much energy are we looking at here? I'll be addressing these queries, providing you with insights that matter. Whether you are a Chia pro farmer or a fresh face in the Chia farming universe, I believe there is something valuable here for you. Alright, no more delays, let's dive straight in. Don't forget to hit that like button and subscribe so you don't miss any of the exciting updates. Now, without further ado, let's get into it. Alright, I'm excited about Chia 2.0 release. I already installed it on my farmers and harvesters. I want to cover as much as I could today in this video, so I'll give you the short version, right, in the minimum amount of time. So let's start with protocol updates, which is the first update. Chip 0012 plot filter reduction hard fork. The increased speed of GPU plotting is great. However, if someone can create a plot too fast in less than 28 seconds and do so economically, they can continuously create and discard plots without storing them on disk. This is known as plot grinding. So in this update, they're gonna prevent people from doing plot grinding or creating plots in less than 28 seconds and then discarding them. That will resemble proof of work, right? So they want to avoid that. That's why this is one of the important updates, the hard fork. So the thing is, to discourage future plot grinding attempts, we and the community created Chip 0012 to reduce the plot filter over the next decade gradually. The final reduction is set to occur in 2033. The update will cut the plot filter in half every 3 years. The first reduction from 512 to 256 will occur at block 5496, so 5,496,000, likely in June 2024. All right, by about next year, right? And if you want to read more about plot grinding, there is a blog post here. You can click there. GPU plotting is real and very fast, so you can read more about it. I don't want to deep dive in that right now, but I know it's been already implemented in Chip 0012. All right. They also they have implemented these new conditions for coins ID calculations, and these pre-allocated soft fork conditions also here in 2.0. So those are the major changes in this 2.0. Now, what we care is about plotting and farming. So let's deep dive into this section. Now, when it comes to plotters, now you have multiple options. So if you go to the Chia GUI here, you click plots and then you click create plot, you'll see here choose a plotter and you see all the options. You have the old Chia proof of space 202, Bladebit plotter 3.0, CUDA plot, that's if you want to use your GPU to plot. Bladebit plotter 3.0 if you want to just use your disk. Bladebit plotter 3.0 if you just want to use plot entirely on RAM. And then the old good Mad Max plotter 1.16 with the latest version here, and I already have a video on that if you want to check out my previous video. All right, so there are multiple options, right? So with the new Bladebit version 3.0, you can create compressed plots entirely in RAM, right? Entirely in RAM using a CUDA capable GPU. So you need to make sure your GPU is capable of doing that. Let's check on that. Plotting here, and then Bladebit CUDA. Let's see. GPU CUDA capability 5.2 NVIDIA 10 series GPU or higher with 8 GB of GPU VRAM. Okay, those are the requirements for your GPU. Alright, in-memory plotting with a GPU is the fastest and most energy efficient way to plot, and it does not use any of the SSD endurance. Alright, plotting entirely in memory requires 256 GB of RAM when using a GPU. So if you're gonna use your GPU, you need at least 256 or 416, which is crazy, when using just the CPU. So if you don't want to use your GPU to plot, you're gonna need 416 gigabytes just for the CPU. Now let's take a look here at the chart here, which is kind of a summary of all the options. First option, CUDA plot using your GPU. You don't need a temp SSD folder, so no SSD. In terms of RAM, you need 256, plot times between 1 and 3 minutes, and the highest energy efficient. And it's already built into the Bladebit 3.0, so already available. It does support compression, so if you want to start compressing plot, you can use that if you have 256. You can also use that to use your GPU without compression, so that will be level 0. Next option, CUDA plot plus an SSD. To compute, we'll use our GPU. For the temp SSD, we need at least 180 gigabytes. It does support 64 gigabytes of RAM or 128. The plot time is between 3 and 8 minutes, and it's highly energy efficient. In terms of status, is not available yet, so it will be in Chia 2.1, so in a future release, and Bladebit 3.1 in a future release, it will support compression. All right, next option, we have RAM plot, so we'll use entirely our RAM available in our system. It will compute using our CPU, not GPU required, non-temp SSD. We don't need an SSD for the temp folder, and it requires 416 gigabytes of RAM, the highest amount of RAM. I do have a system, workstation C840, so we'll use that today to run a test. It does take between 3 to 5 minutes. We'll see. It's highly energy efficient, and it's already available in Bladebit 3.0. It does support compression, so we'll run a 0 level compression, and we'll run another level of compression, maybe a 5 or 6. The last option will be the disk plot. Compute will use our CPU. We need 512 gigabytes of SSD for the temp folder, and then we need at least 4 gigabytes for RAM. That's the longest, and plot time, it takes between 15 and 60 minutes. Energy efficiency is medium, and it was released in Bladebit 2.0. It will support compression in the future. So that's the summary in terms of the options we have right now in Chia 2.0. Let's move on to plot compression support. Now, plot compression increases the number of plots, which is good, right? You want to store as many plots as possible in your disk, increasing the farming rewards. Now the problem is that when you compress, you're gonna have to decompress all those plots eventually when you farm, and that takes energy. So the key takeaway here is with plot compression, the plot size decreases linearly. So you have a linear decrease in the plot size when you compress, right? When you decompress, you need the amount of compute necessarily scales exponentially, so you need so much more exponentially more energy to decompress. Plot compression is entirely optional. You don't need to compress. You can keep farming, the plots that you have right now, and it requires replotting. All plots will still work on Chia 2.0 build. Most farmers will want to think about replotting to get the highest amount of farming rewards. Low compression levels require minimal compute. So low compression or no compression, minimal compute and power overhead for the extra effective farming space. GPU harvesting is highly efficient, with most large farms only increasing the overall power consumption by a few %. So that's good to know. GPU is really high efficient in terms of farming these compressed levels. We'll see until what level it makes sense to decompress, right, using a GPU. Chia 2.0 builds support compression levels C1 to C7. We'll see what level we can compress. A table, the new plot size are here. Let's keep here. Let's take a look here. These are from 0 to 7 and the 9. And this is 0 is the original GB bytes, 101.4 GB bytes. Let's say you compress to level 5. That's the size 81.3. So you have the sizes here for a K32, and then you have K33, 34, and 35. So you have that table available to see how much space you get. All right, let's move on to farming strategy. Be ready for the plot filter reduction that will occur next June 2024. this will double the number of plots needing to be decompressed at each CNH point. So farmers must ensure the hardware doesn't get overloaded when the hard fork activates. All right, so what they are saying here is that most harvesters are likely not to be affected given their farms fall under maximum capacity. So most of us, we are operating under maximum capacity, so we are not gonna get affected by this decompression problem with the filter reduction, right? And it says here, plot compression is and always will be option. So you gotta carefully think about compressing your plots. Chia has tools to help farmers size their plots and pick the best compression rating for the system. And in order to do that, what you gotta do is you gotta go here to the blog post, and here you have plot compression in here. It was published in January 20, 2023 this year. So in summary, I wanna give you the quick summary here. These are the compression level, right? 0, that's the 101.3. But if, let's say, you compress to level 5, you get a total reduction almost 20%, 19.81% of the original size. So that plot turns into a 81.26, saving you 19.81% in size. Now, if you do that, you get 24.67 chances of percent change in reward. So it's quite an increase, right? So it may be tempting. Now, the thing is here, let's see if I can explain it here. Effective capacity versus compression level. The more you compress, you see here it assumes a 500 terabytes raw capacity. If you go into a 7, you get 649 effective capacity, right? So quite an increase. Let's see, no free lunch compression. So it may be tempting to plot at highest compression level to obtain the most storage efficiency and therefore the most rewards, but there is a compute overhead to decompress the plots during farming, which requires extra energy versus baseline farming. So there are a couple of things that you gotta take into account, right? When compressing. So in order to do that, one of the key variables that you gotta use is your power cost, right? Because you're gonna use more energy now to decompress. And in order to calculate this, you need to use this spreadsheet here. You're gonna click here, and this is the spreadsheet that it will tell you exactly what's your best compression level that you should use if you choose to compress. And we'll do that in detail in another video, but I wanted to show you that you have the option here to calculate what's the best level for compression for your farm. All right, so let's say you decide to compress and you go ahead and compress using your GPU or CPU, and you get your plots, new plots, compressed plots, right? How do you farm them? That's a good question. I've been asked that many times. So in the new GUI, what you're gonna do is, well, first let's read here. Farming with a CPU, just with a CPU, not GPU, will take about extra 500 megabytes of memory. So you need 500 megabytes of extra memory if you're gonna farm with a CPU. And the default is set to use half of the user's CPU thread. So how do we do this? We're gonna go to the new GUI. You're gonna hit settings. Then you're gonna go to here, harvester. There, harvester. Enable compressed plot support. So you're just gonna click here. You're gonna toggle that on. And then this is the way to enable compressed plot support. Leave it like that. Parallel decompressor count. This is the number of CPUs you have in your harvester. In this system I have 2. You can type, if you got 1 CPU, just leave 1. That's the default value. You can type 2. Decompressor thread count. Number of threads for a decompressor context. Multiplying parallel decompressor count and decompressor threads count must not exceed the number of CPU cores. So the higher the combined value, the greater the CPU usage required. I'm gonna use just 1 CPU and 12 threads I have here, so I'm gonna leave it at 12. We'll see. Enable GPU harvesting. So if you wanna use your GPU, depending on the level of compression, you want to enable this. So if you want to enable, and remember, it's highly efficient to decompress using your GPU. So you're just gonna enable there. GPU device index is if you have multiple GPUs, specify the GPU index for harvesting. if more than one GPU is present. By default is 0. And then if you apply here, restart local harvester here in red, you apply the changes and you restart the harvester. That's the way to enable decompression for compressed plots. All right, I'm here at the main farmer looking at one of the harvesters that I have. And you can see the option harvest. You see all your harvesters. And you can see I have 1,420 K32 plots, right? That represent 100% of the population. In terms of compression, C0s, I mean non-compression, I have 1410. So, you know, around 99% are no compression. And I just ran a few tests and I created 10. So C5 compressed level 5, 10 plots represent 1%. So, and you can see here in the pie chart. So let's go ahead and go to that particular harvester and run 10 more plots using level 7, which is the maximum allowed to see here in Chia 2.0, right? The GUI supports up to level 7. So let's go ahead and run a few of those and see how much time it takes the new Bladebit 3.0. All right, I'm here on one of the harvesters. This is a HPC 840 and it's farming in all these enclosures, 5A enclosures. And here's the actual configuration. It's an Intel Xeon CPU E5 2690 V3 at 2.6 GHz. It has dual socket here, cores 24 cores, and total of 48 logical processors. Okay, in terms of memory, you can see I upgrade to 512. So I have 512 gigabytes here. So we're gonna use that to test in RAM. And then in terms of GPU, I have a single now NVIDIA GeForce RTX 3070 Ti. So that's the equipment we're gonna use today to test these plots. All right, so let's go ahead and open the GUI here. All right, I just opened up the GUI of the harvester. We're gonna go to plots here. Then we're gonna go to add plot. And then here we're gonna say plot to a plot NFT, which is recommended to plot on a pool. So I'm gonna select my plot NFT there. Second step is choose a plotter. All right, we're gonna use the first one, Bladebit here, Bladebit plotter 3.0 CUDA. So we're gonna use the GPU to start with and testing a few plots with compression. Keys, you're gonna leave that by default, but you can set it up manually if you want. It brings up the keys by default, which is useful. And then choose K value. We're gonna use K32, and compression level we're gonna go all the way to 7. We're gonna fully compress this plot. All right, let's choose the final directory here. This is my D here. That's okay. Let's go in options, show advanced options, GPU device 0 by default, which is the GPU that we have. Plot count, we're gonna create 10 plots. Let's create 10 more plots. Let's go ahead and create here. All right, let's see what happens. All right, there you are. First plot is being created. K32, 130 GB bytes there, default. So it started to plot. So let's see how long it takes. Now, if you click here, you can see the view log, and then you can start seeing the logs about this one plot. Right, it's using 48 threads. There was no warm start. Let's see here, compression level 7, benchmark mode disabled. We're using, the CUDA device 0, 3070 Ti. Let's see, L2 free. All right, here, GPU RAM require. We need 5.72 GB bytes for GPU RAM require. Host RAM require 132. Total host RAM required, so about 216 GB bytes is using. So this right now is allocating to buffers. So let's wait and see how long it takes. All right, and now we have it completed plot 1 in 369.53 seconds. That's roughly that's exactly 6.16 minutes. Although that's pretty good, but although in this machine I'm farming at the same time, I'm doing other projects, I'm running other projects at the same time. So this is I'm quite satisfied with the first plot, right, in 6.16 minutes. We'll see the second plot how long it takes. And now it's saving it onto the D on the final folder. All right, I'm back at the main farmer here, and I can see the plot that we just created showing up here with a compression level 7. That means that the harvester is farming the compressed plots that are being created, right? So you need to make sure you enable GPU harvesting on your harvester. So by that, you're gonna go to your harvester. Let me show you how you do that. You're gonna go to your settings, and then on settings, you're gonna go to harvester, and then again, you're gonna enable GPU harvesting here. All right, and then you need to restart your local harvester here, and then it's gonna start showing up. All right, and we encountered the first error at 90% on the second plot and 90% progress. We get this command buffer full, waiting for command, waited 0 seconds for a command to be available, and it keeps repeating command buffer full, waiting for command. So I'm gonna have to research and see what's going on. It's probably the SSD drive not able to keep up with this harvester, and plotting so fast, right? It's plotting so fast that the SSD is not able to keep up with the amount of data. So I'm gonna have to research and see how it fixed. So let's move on to the next plotter. All right, let's kick off one using the entire RAM that we have on this system. RAM plot method, right? So I just selected the plot NFT, choose plotter. We're gonna choose Bladebit plotter 3.0 RAM plot. So you're gonna plot entirely on RAM. Let's go ahead. For this method, you need 416 gigabytes of RAM. Keys are there. Compression level 7, so we can compare to the GPU plotter. Let's do same folder. Options here. One plot count. I'm gonna use 40 threads. All right, so let's kick that off and see how long it takes. All right, let's take a look at here the log. System memory 482 out of 511. Memory required 416. Okay, I'm looking at the resources being used, and CPU is at 100% right now. You can see all the logical processors being used at a maximum. I had to limit and use 40 threads out of the 48. In terms of memory, it keeps increasing. We are at 303 right now. This system has 512, but we should be using 416 according to the requirements. So we'll see. We're right there, 61%. Nothing else. The output drive is not being used, and GPU is not being used. So I keep monitoring and see how long it takes for this plot being plotted in RAM. Right? We'll see. All right. So this RAM plot is almost done. Now it's writing the final plot tables to the disk. You can see here finish phase 4 in 1.81 seconds. The total thing took like 9.3 minutes, so much more than just using the GPU, right? So I'm gonna close this and start with the next plot. All right, and if you don't have access to huge amount of RAM, you just kick off an old-fashioned disk plot. So we're gonna do that right now and see how much it compares. It's gonna be much slower, but that's an option. I'm gonna use the NFT here, choose a plotter. Still comes with the original Chia proof of space 2.0, but we're gonna test the Bladebit plotter 3.0 disk plot. So we're gonna choose that. Keys, we're gonna leave the default values there. K32 temp. You do need a temp folder, so we're gonna use an SSD. All right. Default is on a RAM. No, that's if you have a RAM disk. There it is. Disable the IO on the temp1 directory in order to extract maximum performance with RAM disk. That if you want to use a RAM disk. Advanced second temporarily. If you have a second SSD, you can use that. I'm not gonna use that right now. And then the folder destination. IX drive there. Options. Number of threads. I'm gonna limit this the same way. 40 threads. Buckets. We are not gonna do anything in parallel. All right, let's go ahead and kick it off. All right, and while we wait for the disk plug to get completed, let's take a look at some of the improvements in the UI. If you go to the farm tab here, you can see the new look. This is really helpful. The farm health, it's gonna tell you the status of your farm, overall sync. plot passing the filter, you'll get an okay, or the number of plots not passing the filter. Missing signage point, you get either none, which is healthy, or you get the exact amount of plots not passing the signage point, which are specific points calculated by the blockchain, right? They are like timestamps for the plot. So if they are not able to provide a valid cryptographic proof, then they're gonna miss, and they are not gonna be eligible for participation in the consensus algorithm. So you wanna minimize that. This usually could be the network issue. Then we have the stealth partials. So again, these are plots that they lost competitiveness, right? They are not they did pass the signage point, but they are not able to no longer able to compete. So they probably lost. It could be like time, right? It could be like there are different factors, but it could be network difficulty, or just it took too long to pass. So they are stale. You don't want to have, you want to minimize all this, and you want to analyze what's the root cause behind. All right, and then you get the Netscape, the total Netscape for Chia network, your farming space here, your farming rewards, estimated time to win, how many days until you win, estimated daily XCH here, and the estimated monthly is here. These are the farming rewards history, how many you won, and the last time you won, you block one on the blockchain. All right, and then you have, this is pretty useful. You the same pooling health you used to see on the pool, you actually see here now in the GUI here. Valid partials, stealth partials, valid partials, and missing partials. All right, really helpful farm, new look of the farm tab. All right, let's take a look at the other improvement in the UI. This is the harvest tab. Now you get the total farm size in raw space, TB bytes, and then you get the total farm size effective, which means it takes into account the compressed plots, right? How much farm size are you gaining by just compressing plots? Number of plots, harvesting effectiveness. These are the eligible plots for signage point, like I mentioned in the previous section. I'm getting 10.66. So these are like this is an average, right? Over the last 64 signage points. So it's an average, and this is with the filter of 1/512. Duplicate plots, you'll see there if you have any duplicates, and then you see each harvester, right? This is the local one, and this is the remote, and you'll see the total space that the harvester is providing plus the effective space, which is with the compressed plots, right? And here you see how much you earn just by having those compressed plots. Let's take a look here. Yeah, here you have I have 1,410 no compressed plots or original plots, and then I have 10 plots compressed to level 5, and then with just one plot that we tested today with compression level 7. So I'm gaining 0.2% of the total space. So that's what you're gonna start seeing here, and you're gonna see the breakdown of the plots here between no compression and compression levels here in this pie chart. In addition, you have this harvester latency, which it gives you an idea of how much delay is the compression adding to your system, right? You have the original harvesting with no with latency, but with no compression, and then I have here some compression, so I can see if by having more compressed plot, it will add more latency, right? Because it's required that more computation. So this new graph will tell me if there's an issue with more plots getting compressed in the overall equation. All right, let's take a look at this plot. It's just finished. I couldn't catch the real-time log, so I'm going to the actual plot log. You can see here, phase 1. Let's take a look here. Let's go all over. This is the last piece. Here it is, final plot sizes. All right, finished plotting in 4,454 seconds. So that's 74.2 minutes. So 1 hour and 14 minutes it took in this computer running other things, right? It's not just a plotter, but still, so much compared to the GPU. GPU comes at first. Okay, wrapping up our dive into Chia 2.0. I know we covered a lot in this video, and it's natural for these updates to feel like a lot to digest at once. So take your time to absorb all these exciting changes. If you want another follow-up video on a specific topic related to Chia, just reach out to me. Don't hesitate. I'm all ears and open to crafting a follow-up video based on your specific interests. Just let me know. I truly hope you found today's contest enlightening and engaging. Your support means the world to me. Thank you so much for tuning in. Keep farming. I'll catch you up in the next video. Happy farming. See you in the next one.